Inverter.
Hi, welcome to clickmyproject.com. The title of our project is an SMDP based service model for interdomain resource allocation in mobile cloud networks. We have extracted this paper from the domain of cloud computing. Let us see the abstract of this paper. Mobile cloud computing is a gifted technology that serves multitude number of mobile devices anywhere and anytime through internet. A general mobile cloud computing system composed of multiple cloud domains. Each cloud domains consist of multiple cloud system resources such as CPU, memory and storage. It is very difficult to manage the cloud resources across the multiple cloud domains. And also it is very critical to provide a continuous mobile cloud services to the mobile cloud users. So, in this paper, we propose a service decision making system for interdomain service transfer to balance the computation load across the multiple cloud domains. It increases the system rewards and also decreases the service rejections. Thus, we are formulating the service request decision process called semi-Markov decision process, that is SMDP. In this, it not only focus a present state, it also consider the future state. The optimal service transfer decisions are taken by a SMDP. It really significantly improve the system rewards and decrease the system distribution compared with a greedy approach. In greedy approach, the decision makings are taken based on current state, not future. Let's see the flow diagram of this project. It consists of client side and server side. From client side, it sends a service request to the cloud server. That's all from the client side. From server side, it receives a service request that are sent by client and check whether that service can accommodate in home domain. If it is, then accept that service request and allocate maximum virtual machine for that service request. Then execute it and end the process. If that service request can accommodate in a home domain, then it transfer the request to the adjacent domains. This interdomain transfer based on SMDP process. Then collect decision from the adjacent domains. Again check any one adjacent domains can accommodate the service request. If yes, select that domain and allocate maximum virtual machine for that service. If else, reject the new service request and end the process. After allocating the virtual machine for that process, then transfer the service to the adjacent domain. After executing the process, produce the result and display it to the client side. Now let us see about brief explanation of our project demo. First of all, we have to upload some file to the cloud server. Before we are going to upload a file, we must start a server. Initially, server in idle state. Likewise, all the servers are in idle state. Now, choose a file and send it to cloud IP 2. Upload a file uploaded successfully. Now check it in server 2, the data has been received. Now we are going to access a file that are uploaded in server 2. This is server 1 IP address, that is home domain of the user. Home domain is starter as well as adjacent domain also starter. Now user going to access the file that is uploaded in server IP2. Type the file name and enter the home domain IP address. Home domain IP address is 44. Send a request to home domain. Requesting file from server. That file is not stored in server IP1, but the file has been received. The request has been transferred to adjacent domain using SMDP process. Now we are going to analyze the dropping probability of service request. For that, we have to calculate total number of access and total number of failures and total number of file access in the cloud server. So service probability calculation graph. In that, it shows total number of access in blue color and total number of failures and total number of success. From that, we can find the dropping probability of service request. This graph used to decrease the service request rejections. Thank you.